Okay, we're going to do section 5 today, and then tomorrow in class we're going to do practice problems, some additional ones for 5. Then Wednesday we'll do 6, and then Thursday practice problems for 6, and then Friday 7, and then practice problems Monday for 7. So I'm going to make sure each section you guys really understand what you're doing. Okay. You still will have big ideas, so you'll have big ideas, and then you'll have the extra practice set that I give you as far as grades for the grade book. And then CK12, you'll still have that as well. As far as the quizzes go, I mean, this year compared to most, I thought I had much better success, and I'm thinking it's because I gave you those extra worksheets. I think I only had a third who didn't pass, and everybody else, I had 100, I had a 95, I had 2 90s, 2 80s, and a 70, and then 3 less than that. So I was pretty pleased. If I have time and you guys want me to, those who didn't pass, maybe we could go through it together at the end of this period, or you can come in on your own time and go through it with me. It's up to you. Depends on whether you want to work on the problems for today after we go through the lesson, or if you want to go through the review of the quiz. So I'll talk to you about that at the end. So today what we're working on is inverse trig functions. So the way to think about this is we use trig functions to find side lengths of triangles. We're given angles, and we can use trig functions to find side lengths. And what I mean by that, if this is a 3, 4, 5, let's just say it's a 3, 4. We don't know it's a 5. Maybe that's a bad example. Let's just do this. So that means that this must be 57. And I know one side length. I can use trig functions to find the other two. Right? I could say, to find this side length, let's call this x, and this y, I could use a trig function. Here I would use tangent. Right? And then to find y, I could use cosine of 57, or I could use sine of 33. Okay, this is why we learn trig functions, is so we can solve lengths of triangles. Okay, what we're talking about today is how to find angles with trig functions. Okay, so anytime you want to find an angle, you're going to use an inverse trig function. So let me give you an example. If I want to find the angles here, and I know the side lengths, well, I could set up a trig function for x, and I could say tangent x equals 4/3, opposite over adjacent. Now I've got to figure out how to solve for x. Okay, so to do this, we take the inverse trig function. That's inverse, something raised to the -1. And I do it of both sides. And this undoes the tangent. Inverse tangent times tangent just gives me the x. So x is equal to the inverse tangent of 4/5. Okay, so in a calculator, what you're going to do, make sure first you go to mode. Everybody grab one if you don't have one. Go to mode. You see where mode is? Right next to the second button. If you go to mode, you're going to see all of the inputs that this calculator is using to make its calculations. 3 down, there's a line that says radian and degree. You see that? In my calculator, radian is highlighted. In order to do your problems, degree must be highlighted. You will learn about radians in trig if you ever take that. If you don't take it, don't worry about it. You need your answers to be in or your calculator input to be in degree. So you're going to arrow over if it's not, arrow down and then over, hit degree, and now it should be highlighted. That's what you want to do all the time when you get a calculator. I've got trig students in here. Sometimes they'll change it to radian, so you need to make sure your calculator's in degree. To do this problem, you're going to type in a clear screen. 4 divided by 5, enter. You get 0.8. Now hit second tan. And you see how it says tan to the -1. Okay, if you want to pull this answer in that you just typed in, just hit second answer, and it pulls it right in. Second button is blue. Answer is right by the negative sign. Not the subtraction sign, but the negative, the bottom. And it pulls that answer in, and it computes that that angle is 38.66 degrees. .66. Those of you who understand your exponents, if I said x to the -1, what does that mean without a negative exponent? How can I convert that to only positive exponents? What does the negative mean? Anybody remember? Algebra 1. What does the negative mean? Yeah, it flips it. It just inverts it. So x to the -1 is equal to 1 over x. So knowing this can confuse some students, because if I'm talking about the inverse of cosine, which I'm working on now to find angles, we learned that the inverse of cosine was secant, right? You just flip it. 1 over cosine is secant. This is not secant. This is secant. Secant x. If I inverse the whole thing. Okay, so if it's written like this, we're looking for the angle. You're going to take inverse cosine on your calculator. If it's written like this, we're flipping the whole thing, 1 over cosine x. 1 over cosine x is secant. Don't confuse the two. And you'll have a problem on big ideas where you have to explain that. That's why I wanted to go through it. This is the nomenclature to find the angle x. Putting everything in parentheses and raising it to the -1 flips the whole thing, 1 over cosine x, which is secant. Okay. So when I take tangent of the inverse tangent of -1, if I had written this, well, that's cotangent, because the whole thing is written in as a parenthesis. If it's just here, it just means I want to find the angle where x is the tangent of x is 4/5. Okay, so tangent of an angle is going to give me a side length. If I don't know the angle, I'm going to use inverse tangent, inverse sine, inverse cosine to find the angle. And why do we do this? We do this to solve triangles, right triangles specifically. If I'm given this triangle and I'm told to solve it, and you're going to have about 6 or 7 of these on your practice problems. It says solve the right triangle. What it's asking for is find any missing side lengths, any missing angles. Okay, how do I find the missing side length here? Pythagorean theorem, right? 9 plus 4 square root. Hypotenuse is the square root of 13. Now, how do I find this angle? There's several ways I could find it. None of them are wrong, but they're all trig functions. What trig function, now that I've labeled my triangle, can I use to solve for the angle x? Okay, if you want to say sine, okay, sine x equals what? 2 over, what's sine, SOHCAHTOA? 2 over the square root of 13. Sine is opposite over hypotenuse. So SOH, sine is opposite hypotenuse. Okay, so if I want to find the angle, I have to take the inverse sine of both sides. To undo sine here, so everybody try finding inverse sine of 2 over square root of 13 in your calculator. What'd you get? 33.7. Yeah, 33.7. Okay. Now I know this is 33.7. How do I find this angle? Yep, I could use trig. What's a faster way? Yeah, or just take 90 minus this, because these two angles together must equal 90. Take 90 minus 33.7. What do you get? Yeah. Okay, this is called solving a right triangle. You have to find all missing sides, all missing angles. You're going to need to do inverse trig functions and understand them in order to do that, to find the angles. Okay, so you'll always use inverse trig functions to find angles. You'll use regular trig functions to find side lengths. And that is it for this section. Let's go through the textbook check. Quizzes. Okay, you use the blank trig ratio to find an acute angle of a right triangle. Inverse trig ratio. Tangent to the -1 may also be called arctan. That's true. It's another way they call it. To try and keep you from confusing inverse tangent to be cotangent. Sometimes they'll call it arc sine, arc cosine. Arc tangent is the same as inverse tangent. Question 3, to find the measure of angle A, you would use inverse tangent of 20 over 25 because you have the opposite and the adjacent. So inverse tangent, which is number 3 down there, of 20 over 25. Question 4, when you're asked to solve a triangle, you need to find all missing angles or sides. True. Question 5, what's the measure of angle A? Well, these are isosceles triangles, right? Isosceles triangles of a right triangle is a 45, 45, 90, which means angle A is 45. Okay. Okay, now those of you who are going to retake the quiz, do you want me to go through it now, or would you like to come in on your own time? Okay. So come in on your own time and I'll go through that with you.